Okay, before I trace through this, try and do the loop counting steps for this loop that I have here. Okay, we don't have two loops, but I'm still gonna call this my outer loop. My outer loop is gonna be using the variable named I, and my I starts is equal to 1. Each time my I is gonna get multiplied by 2, so I will be 1, and then 2, and then 4, and then 8. Okay, and where does it stop? It stops, the last value will be when I is equal to n. So eventually I'll get that I is equal to n over 4, and then I is equal to n over 2, and then I is equal to n. Okay, and then for each of these values of I have to think about the number of steps that happen for that value of I. It's just a constant time operation inside the loop. It's not a nested loop or anything. So for each of these values of I have just a single step. And so my question is, what's the total number of steps? Like, what's that column summed together? And I can think about this value of I as relating to a balanced binary search tree. So imagine on the top row I have 1 node, and then 2 nodes on the second row, and then 4 nodes on the next row, and then 8 nodes on the next row, and then in the end I have n nodes. And these number of steps, it's looking at essentially how many rows of nodes do we have. And we know that the height of a balanced binary search tree is log base 2 of n. So you can imagine that the total number here is log base 2 of n. And I think you could reasonably argue that that's off by 1. So if n is the number of leaves in that bottom row, then we know that the height is log base 2 of n. But we calculated our height as the number of edges from the root node to the furthest away leaf. And here we have a 1 for every row of nodes, not just the edges. So you could think about like, oh, actually this is log base 2 of n plus 1. But in general, we're just going to ignore that and be like, oh, this is in log base 2 of n. This is in big O of log base 2 of n, because things like that plus 1, these additional constant factors aren't going to matter.